Hi everyone. Now let's look at the complementation operation. So you already know that in DFA we have total 5 tuples. So definitely in any language for which you draw the deterministic finite automata machine, the language contains 5 tuples. What are the 5 tuples? Capital Q, sigma, Q naught, delta and capital F. So capital Q denotes set of states, sigma denotes the input alphabet, Q naught is initial state, transition function and then final state. If you apply the complement on language L, then the final complemented language will contain tuples capital Q, sigma, Q naught, delta and Q minus F, which means in the previous language the final state is capital F and in the complemented language the final state is Q minus F. So whatever the non-final states which are present in the original language will be the final state in the complemented language. Okay, so let's take an example. Let's say I have a language L, strings which contain A, assuming that we have two input alphabets, small a comma small b. So what are the possible strings present in this language? Let's say language is L1. The possible string is A, AB, ABA, BAB and so on. If you draw the transition diagram for this language L1, you will get the transition diagram. Capital A as the initial state, then if you see A, then you will go to the final state, capital B, and on final state, I will accept any number of A's or B's, and on initial state, I will accept any number of B's. So this is the transition diagram for language which contains A. On the other side, if I take language L2, so let's say language L1 itself and take the complement. Complement means take a bar on language. So here strings which contains A, so the complemented language will be strings which does not contain A, which strings does not contain A. Okay. So what are the possible strings present in this complemented language? The possible string will be epsilon because it does not contain A. Small b, it does not contain A. B, then triple times B and so on. Okay. So from the definition, the non-final states will become the final state in the complemented language. So here non-final state is capital A. So it will become the final state in complemented and it will become the non-final state. So I will draw the transition diagram easily in complemented language. So capital A is the final state, capital B is the non-final state, and the transition moves will remain as it is. It is capital B, it is any number of A's or B's. So from the diagram itself, you can easily understand that it will accept only any number of B's. And with it will also accept the epsilon. Why? Because if you make initial state as a final state, then it will accept the epsilon in the language itself. Okay. So this is the whole idea of complementation operation. In the next video, we will see the last operation on deterministic finite automata.